this was the computer I grew up with, and it had one font installed on it, that one. I looked at it a lot, and I got used to the idea that a font was 7 by 7 pixels, because you had to account for the spacing in there. And I didn't know anything else. Text editors looked like this. This is GeoWrite on the Commodore 64. And it was all single color. And like I said, I got used to that idea. That's how fonts looked on a computer. Until I saw some stuff from the demo scene. These were guys that were creating just programs for fun, and they made sure that everything looked really nice music, and they sort of created color fonts, and this blew me away. This looked really nice, and they broke out of that single color box, and this was really, truly amazing. So we're now halfway the 1980s. Stuff happened, and now we are here today. And hold on a second, I have to... Where are you? I need those. All right, live debugging. So stuff happened. It turned out to be 2016 suddenly, and then there was this big announcement in Warsaw. And that, of course, was color fonts. and some other stuff. So color fonts, there are 4 formats of color fonts around now. These formats, they rekindled my enthusiasm for the color fonts that I used to see when I was a little computer nerd. And it was really exciting to see that the developments were happening. So 4 formats, and I'll introduce you to them if you don't know them. As you know, all OpenType technology is named after rejected Star Wars robots. So this technology is called CBDT CBLC. This is basically a color version of a table that has been around, a pair of tables that have been around for a long time. They contained single color bitmap fonts, except now they are in color. So they are basically just PNG graphics inside a font. These fonts can have multiple strikes. Multiple strikes means that you can have like a 24-pixel version, and you can have a 64-pixel version. They're all in the font, and according to which font format, which font size you set in your document or on the web, it takes the best strike. So you don't get a 20-pixel PNG blown up to really huge sizes. But there is a limit. If you go above that, the biggest PNG in your font, then it will start to look blurry. That's just how bitmap fonts works. Also, a weird requirement of this spec is that there shouldn't be a glyph table present in the font. And the glyph table, of course, holds the regular old black and white fonts, glyphs. So this either works on your machine or you see nothing. The second one, SBIX, it's the format by Apple. It was originally theirs. They didn't open source it. It can contain PNGs, JPEGs, and TIFFs. So still bitmap. And I think their own implementation also supports PDF files. So there's somewhat of a vector variant you could make from an SBIX font. It also contains multiple strikes, so that you can do a small font, small glyph with less detail on small sizes, and a bigger one with more detail for large sizes. It can be combined with outlines, so optionally you can say draw the bitmap and draw the glyph, the regular glyph, on top of it in practice, because this is really buggy. I think this is the font format with the widest support at this moment, because it's on all the iOS and OS X machines. So that was format number 2. Number 3, color CPAL. It's format designed by Microsoft, or proposed by Microsoft, and it's a pretty simple format, but very effective. It just simply uses the glyph table and has some glyphs in there, and just says stack these on top of each other and give each layer a different color. The color table says these are the layers, and the CPAL table says these are the colors for each layer. Because these are regular old glyphs, you can still hint them, and you have access to all the OpenType features that you want. The downside, how you want to look at it, it can only have flat colors, solid colors. Well, not solid colors. You can feed the CPAL table RGBA colors, so that it's red, green, and blue, and matter transparency, going from fully opaque to fully transparent. And then you have the 4th format, SVG, and that can do everything, for better or worse. So I'll take a closer look at the SVG for now, but in a nutshell, it uses SVG images that are stuck in a separate table, the SVG table, and instead of grabbing a regular glyph and drawing that on the screen, it takes an SVG image and draws that on the screen. Let's see. Cheers. Oop. All part of the presentation. So, SVG is a versatile, mature vector format that's been around for a long time, and it can mimic the other font formats, because you can stick PNG images inside an SVG, and you can more or less simulate SBICs and CBDT, CBLC with that. But it can do more. It can do gradients, transparency, and animation, that holy grail of typography. Also, within SVG, you can easily reuse parts. If you have a big SVG document, you can like components, they can reference each other, and you can reuse a lot of stuff. And also things like gradients. You can have one gradient in your document and repeat it for all the glyphs. And from a web point of view, browsers already know SVG, so it's a very low threshold for implementers to implement SVG in the browser, OpenType SVG. But that's also a bit of a downside, because if you want to implement OpenType SVG in somewhere else than a browser, for instance Photoshop, which they did, you need a pretty complex SVG renderer engine, which includes basic CSS support, because color will be passed to the different shapes inside your SVG document by CSS variables. The SVG in itself needs a DOM, like a web page. It's basically a mini browser that you need. So that's quite a big threshold for implementers, and it's a lot more work than, for instance, the color CPAL version. Also, a bit of a problem is that minimal support is kind of vague. It's not clearly defined what of the large, vast SVG spec should be implemented in the OpenType SVG spec. And I'll come back to that a little bit later in the presentation. But for now, a small demo. I want to run through a few of the features that SVG can offer us. At least that came to my mind. But I'm a web developer, computer nerd. I'm not a type designer. So SVG can do plain old solid shapes. So simplified, it can do everything that you can do with a glyph table or a CFF table, I suppose. Except it can't be hinted. It can do color, of course. So you can give each shape a different color. You can even feed it gradients. Oh, these are definitely not made to be beautiful. I feel the need to tell you that, but maybe you've seen that. Yeah. This is just a demonstration, practical demonstration. All right. Opacity, you can feed it RGBA colors that have transparency, or you can say to a shape, you get a normal color, but your opacity is half or something. Patterns. This is another ugly one, but what I want to demonstrate here is that if you have a pattern, you have one small pattern in your entire font, and you can repeat that everywhere. So if you want to have this glyph filled with like raster dots in a regular glyph, you have to draw each and every single dot, and now you can just have one pattern with all the dots, and the computer will draw them on the glyphs for you. You can stick bitmaps in there, and get ready for this one, you can animate them. Yes. So if you think this is bad, then SVG will really ruin your day. So SVG2 is a spec that's still being developed, and people are still talking about what you will be able to do with SVG. One of the things that you can do will be audio. So you can imagine a typewriter font making a nice click.mp3 sound if you have it, or the pile of poo emoji that farts whenever it's used. I told you, this is serious business, serious typography. You can embed videos, so you can watch a high-definition version of the matrix inside your glyph. Why not? A little less weird are filter effects. These are effects that you might know from like Photoshop. You can give a glyph a drop shadow. You can use blend modes, so you can have like translucent parts of your glyph shape. So not opacity, but like the blend modes that you know from Photoshop probably. You can blur your glyphs if you don't care about readability. You can give it a light source, so you could like feed it a sensor on your computer, and then it will apply ambient light to your glyph. And this one, this is a filter called turbulence, and it kind of wobbles your glyph in a random kind of way. So you can really properly create those random grunge fonts that I hear you all so crazy about. So we have these 4 formats now. I can put your mind at ease. SVG2, probably none of that stuff will make it to OpenType SVG. So We have these four formats. The first two that I showed were bitmap fonts, and you cannot really influence the color of those very much. But you can change the colors of the glyphs in color CPAL and in SVG. And how do we do that? Well, we have the CPAL table. The CPAL table contains a list of palettes, and those each contain a list of colors that are available to you. It can optionally contain names for those palettes and for those colors in case humans have to use that font and want to pick a color by the same name. And you can feed it information about which palette type one of the palettes is. For instance, you can tell the font can tell the browser I have two versions, one that's proper for a dark background, and I have one for a light background, and you can mark that in the CPAL table. So you don't actually have to pick a color or a palette. You can just say, give me one that works on a dark background. The CPAL table looks like this. This is the one without the named versions. It has one palette in there. It has two colors. One is red at full opacity, and it has a green half transparent. It has a value of 80 there at the end. So these are the colors that you would be able to use in your color font. In combination with the color format, this is the way you do it. This is an entry for the euro sign, and it says if color fonts are supported, if CPAL, color CPAL is supported, instead of drawing the regular euro sign, take the glyph called euro layer 1, put that at the bottom, and give it color number 0. That would be red. The layer on top of it, give it color number 1 from the CPAL table. That would be that half transparent green. In SVG, something similar happens. That it's supposed to work like this, but there are no real implementations that I can test this against. But you can say I have a path in there, a shape, and I want to feed it color number 0 from the CPAL table, and if that's not available, use the color red. And if color number 1, the half transparent green, is available, use that, otherwise fall back to green. In SVG, you can also hard code colors, so you can just put a real color value in that fill field, and the shape will use that, and you cannot overwrite that. There are alternative ways to squeeze color out of that font. You can tell the browser can tell the font, this is the color that the user has picked, like in CSS, and that's green, and you can feed it to the font. So you can take that color as a base color or something for your glyphs. And you can then mix that with black and white, for instance, and create shades, or fake shades. And another way, kind of a clever way in the try-down color font that Photoshop, that Adobe has released, they use stylistic sets, and each set has a different color. This is obviously not the way to go, but that's the way you have to make it work today in these basic implementations that we have. So, how do color fonts work on the web? If they work like that. If they don't work, they fall back to the regular old black and white glyphs. That's pretty straightforward, I think, except for the CBDT CBLC format, which says we don't want any glyph table in there, because then you might be able to read our text. Then this browser would just be a white screen. You can load the font like regular. This is a good old CSS font face rule, loads the font. You can apply a palette. This one, I tell the H1 tag, we are applying this color font, and our background is dark, so give me a palette, give me a set of colors that works on a dark background. But you can also create a custom palette. This is all still pretty new. This is in the CSS4 draft. You would be able to define your own palette, and here I'm defining toxic green for this specific font, and I know that the third palette in there, that is my greenish font, and that's the one that I want. And I apply it to the H1 tag, for instance, like this. But here's the fun part. You can override the colors in one of those. So if I want, instead of toxic green, I want toxic pink, I can just take the base palette that was toxic green and override all the colors, like red, half transparent, that's the first color, and then RGB, that's purple, the second one, and the third one will be pink. So I told you the CPAL table can also contain human-readable names for those palettes, so why not use those? Well, the problem is you can localize these. So that means that in America, your font can have a palette called toxic green, and if you would create a website based on that, and you say, give me the toxic green palette. If you go to Germany, that would be called giftig grün, maybe. And then it would stop working, because it cannot find, it's asked to give the toxic green palette. There is none. Okay, but does any of this stuff actually work? These color fonts. And I'm happy to say that today, in front of all of you, I can answer that with a resounding, well, sort of. Now, well, there are caveats, and for that I created, to test what works and what doesn't work, I created a font called Lapis Legit. That's this kind of cake, it's a color layer cake, get it? So this is a stress test font. It tries all the silly, weird things that an SVG font could possibly do, so you can check out if it actually works. In the first column, that is the actual glyph in an actual font, an OpenType SVG color font. And these are versions of the same image, but then just as an image in your HTML page or an iframe or embedded. So you can kind of compare what is supposed to happen. And it tests all kinds of things like animation, CSS transforms, opacity, sticking iframes in there. Another one of those typographic holy grails, I think. You can put an actual website inside a glyph, inside an SVG, and then put that SVG inside your font. So that can be useful. Text elements, you can just take a text, like a string of text, apply Comic Sans to it, stick that in the glyph, and then present that to the user. So I've been testing all of these things, and there are two browsers that support OpenType SVG at this moment. It's Firefox and it's Edge, Microsoft Edge. And there are quite a lot of differences. This is a random screen snap from those two browsers next to each other. And like for instance, Edge here doesn't show that it's an animating GIF on top. It doesn't show that. Luckily, it doesn't show the text element. Firefox does for some reason, so there's your Comic Sans inside your glyph. This is a glyph. this is the letter R that you're seeing there, the ABC. And Firefox also supports, oh no, that's the text element again. So you can see there's a lot of differences here. There are even more if you check all of them. Photoshop supports OpenType SVG as well, and obviously they don't support stuff like animation at all, which is good. If you, this is like a snapshot of what works right now, and if you want the basic shapes, you can use them everywhere. Like basic SVG, nothing fancy, that works everywhere that OpenType SVG works. CSS animations work nowhere. SMIL animations, on the other hand, SMIL is the technology specific for SVG, to specifically animate SVG elements. That works in Firefox, and you can, well, this is the animating glyph. Yes, the text element, although the spec says, please don't support this, Firefox does. Bitmaps, for some reason I can't get them to work in Edge, although Edge says that they support it, so I don't know what's going on there, but this stress test font at least shows that it works in Firefox and Photoshop. And CPAL colors work nowhere yet, at least not with my tests. And this is a bit of a problem. You have this format, and you want people to be able to rely on what it can do. And we're not there yet, because Microsoft has to publish a list like this. This is our subset of SVG that we support. And you don't want everyone to say, okay, we support SVG, OpenType SVG, and this is what we do support, and this is what we don't support. So I think I heard signals that they are working on a basic list of minimal support for SVG. So that's good news if you don't want to keep track of lists like these. So what would happen if you stick them all together? All those formats into one font. If you would want to use color fonts on the web, there are two approaches basically you can do. You can check which format is supported and then present the proper format to the user. I wrote a little tool for this. This is called chromatic. And here you can see in Firefox it supports color CPAL and OpenType, SVG and OpenType. So then you could make a choice and say, okay, in this case, I think I'll serve the color CPAL font to the user. Or you can stick them all together in a font and give that to the browser and let the browser figure it out. I tried that. Bungee by David Jonathan Ross is a font that has been released as a color font, and it's been released in all the formats except CBDT, CBLC. And it contains two colors, 287 glyphs in the purely horizontal version, because it's originally a font that also works vertically, but these are just the horizontal glyphs. The regular font is 31 kilobytes. The color font is more than twice as big, 75 kilobytes. The SVG is getting a huge 284 kilobytes. And the SBIX fonts, because it contains a lot of PNGs, it's a hefty 18 megabyte. So what would happen if we stick them all together? I took a couple of steps. I pruned all the fonts. I used the PIFT subset, a tool that's been supplied with TTX font tools. It removes all kinds of stuff that is not used in the font, or not essential at least. I optimized the SVG images because you can usually, when you export them from Illustrator, they are full with metadata and stuff that you don't need. Optimize the PNG images, more or less the same way. And I tried removing the strikes, so instead of having all those 280 glyphs at one size and then another and then another, I just kept the largest one and hoped that if it scaled down that it would still look good. So I kept one strike. The result, one font with the normal fallback glyphs and 3 color formats inside there. 7.3 megabytes. And a WOF of 6.7 megabytes. And a WOF 2 was around the same size. Yeah, this doesn't, you're not going to use a 7 megabyte font on the web, I hope. But let's test and see what happens. Threw it at some browsers, and here are some random conclusions. Firefox and Edge, they will take the font and they will prefer SVG over color if they are both in there. And Edge will take SBICs over the rest. Because Edge, by the way, supports all of them, all 4 formats, so that's pretty nice. But unfortunately, it does pick SBICs over the rest, and that's kind of bad because the scaled strikes look bad. Plus, it's the bitmap version. While if you had the SVG version or the color CPAL version, you would have proper vector images that would scale really nicely. Safari, that supports SBICs, doesn't turn off the outlines. That means it draws the nice SBICs PNG version, and a nice colorful one, and then puts a black glyph on top of it, and then you cannot see your color glyph anymore. There is a flag in the SBICs table where you can say, please do not draw the outlines, but it doesn't listen to it. Edge tries to compensate this. By the way, you cannot turn them on in Edge. So, Photoshop takes SVG over SBICs because they also support both SVG and SBICs. So, like I said, you don't want to use a 7 megabyte font in your website. People are complaining, especially web developers, if there is a version of 32 bytes of your font and there's a version of 35 bytes of your font, why are you using the 35 one? Because you can use that one that's 3 kilobytes smaller. So don't bring then the news that you're going to use a 7 megabyte font. But it's not just download time, it's also render time, because especially the SVG solution, like I said, you basically need a mini browser to render those glyphs. And inside the browser, that kind of means, like, you could imagine that as an iframe for every single letter on your screen. And if you combine that with silly ideas like animation, then your fan will be really, really going fast. So I have deliberately not been showing you any examples of color type and all the rich history of color type, because you know more about that than I do. But one interesting thing that I came across that I want to share is if with the basic support that we have today, you can also use just one color and a support color, for instance, something like this. This could take the regular color from CSS that's been supported right now. So the CPAL table doesn't work yet, but at least you can pass your color font the regular color that you set in CSS. And then you can use black to transparent gradient to create these pseudo layering 3D effects. Another example is, this is basically the same trick applied in a different way. You can fade the current color to transparent, or multiple transparencies. And you can do that layering trick where the color that you feed is orange, and then you put a half-transparent white layer on top of it to create the light orange, and the drop shadow is a regular old black. Here's another trick to use the color black in combination with your current color, and opacity and gradients to create also some sort of 3D effect. And you can also create, of course, the grungy pencil kind of fonts. I'm sorry for the contrast. This is an SBIX font, a PNG font. I cannot change the color. Stupid color fonts. Right, so we have gone about half an hour without talking about variable fonts. So let's give you your fix. Variable color fonts. Are these a possibility? And I'm happy to say that today, in front of all of you, the answer is a resounding yes. We can have variable color fonts. The Microsoft guys touched upon this this morning already. You can use the color CPAL table. And I'll show you how that works in a minute. But I first want to get the caveats out of the way, because it works today on Windows 10 in the Edge browser when the font is installed and has named instances and has been applied as separate families. That was shown this morning as well. All right. So with this information, I teamed up with David Jonathan Ross, and we created a test glyph. It's an emoji. I'll show you here. This is Mr. Pooh. He has a variable cap height. And so this is Windows 10. This is actually a proper working, well, not a proper, it's a working color glyph. So let's take a look at Mr. Pooh's internals. Gross. How does Mr. Pooh look from the inside? The shapes of all of what you just saw, the head and the turd and the eyes and everything, they are just regular entries in the glyph table. The color table stacks them on top of each other. The CPAL table feeds them the color. The variation instances are in the FR and the stat tables, and the actual cap height differences are in the GVAR table. So I'm using JavaScript to run through all those family names to get the animation going. And if you would do that in CSS and you would just want the extremes, then you say font family Mr. Pooh, that's the font family, and then the cap height low is the instance for the small head, and cap height high is the instance for the tall head. Right. So let's give a little bit more demo. Erik van Blokland showed you yesterday a clock. Well, let's see if I, yeah, there we are. And we can do this in a variable color font as well, of course. Yes, there we are. So you can have an axis where you give the clock emoji the proper time. You can animate this from CSS. And it could be useful. The levitating businessman, one of the more useful emoji. Maybe you want to change his levitationness or something. Yay! Or you want to put him back on the ground and turn him into businessman. So I should note these are mock-ups in SVG. You could theoretically do this today in a color font, but I just chose the easy way, and I thought maybe if I don't tell you, then I get away with it. So it's too late for that. So the hand emoji, yeah, well, maybe you want to customize it and tell people about your run-in with the jacuzzi. Jacuzzi. Yes. They chop off your pinky if you misbehave, or you like or Donald Trump and you have tiny hands. Or you think, fucking color fonts. This is not serious typography. All right. Yeah, maybe you want a variation axis for the tongue, and so you probably don't want this, but and I wonder how this would work, because this, if you want this, you will have two axes to have just for this one emoji. And if you wanted to do the clock thing, you have three axes for the clock. So I suppose each glyph, each character gets their own set of axes, or maybe they can share some of the axes. Problems to be solved on another day. So this can be done as a variable color font, but you can only animate the shapes. You cannot animate, or you cannot variate the color. You can only change shapes. So if you wanted to have a smiley that becomes angry or sad, that's very well possible with any old regular variable font. But what if you want to change the color of his face when he is really angry? You wanted him to turn red. Color fonts, goddammit. And you cannot do that except for this little trick that was also shown yesterday, I think. It's the substitution trick, that once you go below a certain threshold, you swap out that particular part of your glyph with another one. So you could say, that's the dollar sign trick, where you have the bar through the dollar sign, except at small sizes. You just don't bother with the middle part and only show the top. So you swap out a glyph at a certain point, and then it would look like this. Bloop. But like here his face is still normal, and then here you get this threshold, and you basically pick a completely different glyph in the glyph table, and then CPAL says, the color table says, you're referencing another color. Instead, the original one references yellow, and this replacement references orange. So I just replaced that. But you get this effect that there's nothing going on, and then suddenly the blood rushes to his face, and that is not how biology works. So we want to do this better, and that means that you will have to combine, if you want to do this, you have to combine variable type with color type, and that works. You change the axis and you change the color through CSS, and then you get this perfectly natural smiley that turns very angry. So these are two things that work together. You change the color in CSS and you change the axis. So I don't blame you if you think these experiments are silly, because they are. These were just ways for me to find out what works and what doesn't work, and what can we break and what can we fix. And I'm sure that none of this will hopefully ever see the light of day as a proper font. But I hope this makes you enthusiastic about some of the things, in the same way that old color bitmap font made me enthusiastic back in the day. And on that note, thank you very much.